All right, now we're going to discuss the branches. So branches, let me jump into here. So branching is a very important Git concept. That's actually one of the reasons it became very popular, because previously many of the source code didn't have the concept of Git, they adopted from the Git. There's a concept that you will be able to create multiple branches for different reasons. When you start working with Git, if you remember, there was a master branch. There was something named master, which was like the main branch. That's actual in many work settings. The master branch should keep the code which is completely release ready. Means that if you copy it into the actual application in the production, it should work without any bug. Means it's tested, it's completely work, and nothing has a problem. But there's also an important discipline within software engineering teams that you should not make changes directly into master branch. So what you have to do, you actually have, for any modification or any change, you need to start to create branches. And they're called basically feature branches. For any bug fixes, for any new task you want to create, you basically have to create a new branch and then be able to make your modifications there. In some of the teams, again, based on the practices your team follows, you can have multiple branches. Master is the one which is ready to release. Staging is the one which is one level before that. You want to basically test it on a test environment to make sure you basically can be pushed to the master. And also there's a development. The development is basically most of the time is the branch that is accessible by all of the software engineers, in our case, by all of the machine learning practitioners and data scientists, that they can basically create branch and start doing their modification. When you start a branch, what it does, it basically copies your entire source repository into a logical concept of branch. So all of the modification you apply there will not have any impact on the parent branch. So it's completely safe to make all of the modification. So once all of the modifications are done, you need to bring back the changes to the parent branch. It's called merge action. So we want to practice here that how it looks like. So first of all, I run branch AVV, which is like a argument, but you can also call A, which lists all of the branches for you. So right now I do have a master and I do have a remote master. So it tells me that there is a master in my local computer and also master in the remote repository. Now, going back to that task, I want to create a hyperparameter tuning feature branch. Why? Because I want to start optimizing my model. I want to basically being able to do some hyperparameter tuning. So when I create when I basically hit this, what it does, it creates a branch on my local computer. Again, the remote repository has no idea that I created a local branch here. That's completely on my local repository, my local environment. All right. So the next step that I have to do before being able to actually apply any change is to basically switch to that branch. So right now, if I click status, I see again everything is up to date, and I'm actually on the master branch. Although I created hyperparameter tuning branch, I'm still in the master branch. In order to switch, I need to hit checkout. So it means that now my branch has changed to hyperparameter tuning. Again, if I click status, I see that I'm in the hyperparameter tuning branch, right? So again, when I activate my VS Code, you see that this button is now hyperparameter tuning. It's not master anymore. It means it's changed. So now I start to apply some modification in the hyperparameter tuning. I want to play around with it to see what it does. So first of all, I want to make some modifications to the training code. So like I added this one. So let me fix it. And because it didn't have any space interned at the end, it just concatenate that way. And then I want to actually create a util.py function, .py file. You see that there is a util.py is created. Now I want to basically stage everything to the indexing environment. Do you remember again, add indexes everything. But because I'm in the hyperparameter tuning branch, it will be indexed within that environment. It's not indexed within the master branch. Now I hit commit, means that all of the changes are now applied to my local repository. All right. So now jump 2 steps. Please remove these 2. Jump 2 steps to the checkout master. So now I'm in the hyperparameter tuning. I want to switch back to the checkout master. So when I check out to the master, you see that this util.py has gone and this change has gone. We don't have these changes anymore. Means that I'm actually going to another version of the code. Again, if I go back to the checkout to the hyperparameter tuning branch, I see all of these changes again go back to my local computer. But it's important to know that this branch is only on my local computer. And most of the times, again, that's a very important practice in software engineering team. They do not let you push your feature into the remotes. They want you merge it into the local master and then push it to the remotes, right? The only reason that you would have a branch within the remote is basically to have those major branches like master, staging, and development. For other branches, it's advised not to do that because it will make a lot of. Imagine if a lifetime of a 2 years project, it will have so many branches, and if every time you want to push it to the remote, it will become super complicated and messy because there's going to be a huge long list of branches there. Now, in order to just show you how basically you need to do that, imagine this is an important major branch. If I just hit push within the hyperparameter tuning, it tells me that there is no remote repository for me to basically submit this. Again, if you remember, push is to send your changes to the remote repository. So in order to do that, I need to first add the upstream repository. Then I can basically make my pushes for the feature branch. So by running this command, I'm basically creating remote, connecting my local branch to a remote repository branch. It means I'm making my branch a tracking branch. That's a term we mostly use. Again, the push doesn't work on at least my Jupyter. I basically restart this and run it on the terminal. Again, copy this if you have also having the same problem as mine. Just copy and paste it into a terminal and then run it there. So when I run this, so basically now my branch has a remote remote presence basically in the remote repository. So when I go to the GitHub repository I just created, I'm able to basically see that I now have 2 branches. So if I click on it, I see that there's a hyperparameter tuning branch and also there's a master branch. And also when I go back to the actual code, I can basically see all of the changes. I can basically switch between these. So I can pick any of these 2 branches and see the code from that perspective within the remote repository. Okay, this is very important, creating a remote branch for our pull request and also CI/CD pipeline that we're going to discuss later. All right. So I'm going to skip the concept of merge for now. No, let me do it because that's important. All right. So now we're going to go back to the concept of merging. So what does merge mean? If I go back to this diagram, every time you're creating a feature, you basically will create a branch. When every time you create a branch, it will basically this this dot will keep all of the code which you have changed up to here from the development branch. All of the modification you made here now has to basically pushed back to the master or to the parent branch. That is the concept of merge. Basically bring that back to the original parent branch. You can of course merge it to anything anywhere else, but that's not of course suggested because it will create a spaghetti. You will basically really hard to find a lineage. In order to merge, what you need to do, you need to go to the parent branch, and then you need to run the command merge. I will not go through this command. That's important, like search for fast forward merge. That's a concept which I'm going to take time to explain. But what it does, it basically submits this this request. It basically have made all of the changes that I made to the master branch. Now if I go to the, again, GitHub UI, go to the insights. Oops. Again, the changes happen on my local computer, right? So I need to push it to the origin. And I forgot that. So now I need to hit push. Because I'm in the master branch, the push means pushing the changes to the master in the remote repository. So again, I need to run it on my terminal because it doesn't work on Jupyter for some reason. Now because I pushed it to the remote repository, if you go to the insights and you go to the network, it will be able to see this little merge. So I actually was able to bring that changes back to the master branch. That's really important because the lineage will help you again to understand all of the changes in the past, and that's very important in any team who actually versioning is important for them, especially for their code. It's actually cool to go to let me go to the incognito because I want to show you anything internal. So you can basically pick a repository, open repository, and go to the insights and check the network. You will see like big mess, especially for those who are pretty long. You will see a lot of interesting changes happening in the past for their, like, I'll go to the VS Code, I'll go to the insights, and I'm able to see the network. And if it is private, repository, you're not able to see it on the free accounts. You need to, it has to be public, basically. So again, I can see the network for the VS Code, and is pretty long to basic and heavy to load. So I give it some time. All right. So now what I did, I had a branch, and now I had a merge. But for many teams, that actually is very bad because any person can basically change the master, and that's scary. So there is a concept called pull request. And the pull request means I want someone to check my changes and then let me merge back to the master or the parent branch. So in order to like simulate the pull request action, again, I'm gonna create, I'm not creating a new branch from the master. This is a short term for create branch and checkout. Basically, it creates a branch and it will check out there. Now I basically run a couple of changes to the hyperparameter tuning, Bayesian optimization. I think you like it. Now when I see, again, when I check out, I will see that the branch here is basically the hyperparameter tuning, so everything turned back. So now all of my changes are applied to the hyperparameter tuning, Bayesian optimization branch, and again, I want to create some more changes. Like again, I did that. So once I'm done, I want to stage and commit it to my local repository, right? And because it is an important branch, I want to have a remote presence for this branch again. But you should be cautious whenever you want to create a remote branch. And I again forgot that it doesn't work on my computer. So let me copy and paste it here. Okay. And now it is actually available in the remote section. So if I go to the GitHub page, I'll be able to see basically a new branch is added here. You see that, right? So now instead of running the merge just without checking, I want to actually create a pull request. So the pull request can be programmed in a very complicated way. So you can basically only assign it to very few people. So imagine if you're working on an open source project, when you want to submit your changes to that repository, you cannot directly submit that. You need to create a pull request, and it will go through a couple of editors and reviewers to see your code, to check whether your code is good, is high quality enough, and etc. And also, a little bit later, we will show you how you can basically run a couple of tests whenever you submit a pull request. So that instead of having a manual review, you can also back it with some automated test to make sure the test and everything works fine and your code works fine, it doesn't break basically. So here I'm actually like creating a pull request. I want to basically bring it back, merge it with the master. When I hit create, I can also provide some assignees here, like in real world, you will have to provide some because you will not be able to basically create if you create it without any assignee. People will have hard time finding your pull request. And then once it is basically sent, it checks whether there's any conflict or not. If not, it will be able to merge it back to the actual branch. And now the merge is accepted, and my master has the changes from the feature branch that I just created, right?